Hello everyone. In this video we are going to solve an exponential equation, an interesting one. Of course, we have 4 to the power s minus 7 to the power s equals to 9 to the power z, or equals to 252. And then the question is to find what 1 over s plus 1 over y plus 1 over z equals to. So now let's look at this. Now I'm going to solve this using 3 different methods. So we are going to use this 3 different approaches in solving this question. So now let's get into it. Now for the first part, so we have the first method. In the first method, remember we have 4 to the power x is equal to 252, right? And then the second part is 7 to the power y equals to 252. And then the third one is just 9 to the power z equals to 252. Now, how do we find x in this case? It's basically just by applying ln on both sides, right? So let's apply ln on both sides. So we have ln 4 to the power s, and then ln 252. And then in this case too, solving the whole of that, I'm just going to have, so this moves to the front. I have s ln 4 being equal to ln 252. So to make s a subject, it's just going to be ln 252 divided by just ln 4, right? So now with the first part, it applies to every part here. So you realize that just that this place is 4, this place is y, and then the 252 is there. So you realize that y here is basically, using this approach, you realize that y here is basically going to be equal to ln 252 divided by just ln 7, and then z here also becomes z equals to the ln 252 divided by ln 9, right? Just applying this approach here, we are going to get this, right? Now in this case, since we know what s, y, and z is, now the question says what is 1 over s, 1 over y, and then 1 over z. So in this case, what I'm going to do is that remember we just have x, so which means that in this case x, if s equals to that, then which means that 1 over x here is just the reciprocal of that, so it becomes ln 4 over ln 252. Then we have 1 over y, so 1 over y also becomes ln 7 over ln 252, and then 1 over z here also becomes ln 252, so ln 9, sorry, divided by ln 252 in this case, right? So if that is the case, then we can therefore say that now from the question, 1 over s plus 1 over y plus 1 over z will be equal to, now what is 1 over x? Learn that 1 over s from the previous equation is ln 4 over ln 252 plus 1 over y is just ln 7 divided by ln 252 plus 1 over z is just ln 9 over ln 252. So in this case, the LCM becomes ln 252, right? And then we have just ln 4 plus ln 7 plus ln 9 here in this case, right? So from here, from properties of log, you realize that if you have ln 4 plus ln 5 and then the bases are the same and then they are adding, all you do is to multiply the numbers. So I can just factorize this out, and I have ln 4 multiplied by 7 multiplied by 9 divided by ln 252. Now what is this? Now the whole thing here, it amounts to 4 times 7 times 9 is just 252 divided by ln 252, and then when it cancels, everything goes to 1 in this case, right? Now this is basically the first approach. Now let's look at the second method. Now in the second method, so with the second method, now remember we have 4x equals to 252. We have 7y equals to 7 to the power y equals to that, then 9 to the power that equals to that. Now from properties of logarithm, right? Now when I apply log on both sides, or basically I'm just turning it, I'm reversing the whole thing, because this formula, this whole thing can be written as just taking this back and then bringing this down, right? So when this whole thing is like looks like this: s equals to log 252 to the power 4, right? So 4 comes to raise that up and becomes 4 to the power x, and then we have the 252. That's what you see over here. So I'm just reversing the whole thing. So y equals to the log base 7 252, and then over here z equals to the log base 9 252 in this case. Right now, since we have something like this, now the question says that what is 1 over x plus 1 over y plus 1 over z, right? Then remember that we have s to be that, y to be this, and then z to be this. But then what is remember, this is what we are looking for. But then what is 1 over x, right? If s equals to that, then which means that it will be 1 over the log of 252 and then base 4, and then this will also be equal to 1 over the log of 7252 equals 1 over the log of 9, log base 9252 in this case. Now, from properties of logarithm, right? From the properties of logarithm, if you have something like the log 1 over, let's say, log base ab, right? From properties of logarithm, this is basically equals to the log base, it becomes base b and then a here, right? That's one property of logarithm. So if that is the case, then which means that we can change this whole thing into that, right? So in this case, we have the question says that what is 1 over s plus 1 over y plus 1 over z in this case, right? So if that is the case, then which means that 1 over x is basically using the formula here, then 1 over s will be equal to the log 4 here 252 plus log 252, then we have 7 plus log base 252, and then we have 9 in this case. Now then again, from the properties of log, if we have something like that and the bases are the same, this whole thing goes to 252 here and then multiplied by 4 times 7 times 9, and then this just gives you 252. And then another property says that if you have a log of base a and then you have a over here, this is basically equal to 1. If what is over here is equal to what is over here, the base and then the index are the same, then you have it equal to 1. And in this case, we have 252 and then 252. So therefore, 1 over x plus 1 over y plus 1 over z here equals to 1 in this case. Now, this is the second method. Now, let's look at the third method. So with the third method, right, this is the third method. Remember, it is 4 to the power x, 7 to the power y, and then 9 to the power z, right? Now 4 to the power x is equal to 252, which can be written as now is also equal to 252 and then equals to 252. Now what I can do here is that because we are finding what is 1 over s plus 1 over y plus 1 over z, why don't I multiply both sides by the reciprocal of the exponent on both sides? So if I have 4 to the power s, it becomes 4 to the power x multiplied by 1 over x, and I do that on both sides. So we have 1 over x here, so this place becomes 7 to the power y multiplied by 1 over y equals to 252 1 over y in this case. And then this place also becomes 9 to the power z times 1 over z equals to 252 to the power 1 over z in this case. So we realize that with all of this, we just have 4 equals to 252 1 over x, and then we have 7 equals 252 1 over y, and then we have what 9 equals to 252 1 over z in this case. So this is what we have. Then also remember that what is that? So just multiplying this side. If I multiply this side and I multiplied all of this side, you can see that I'm still going to get the 1 over x plus 1 over y plus 1 over z. Why? Because in this case the bases are the same, and if from properties of logarithm of indices, if the bases are the same and then they are multiplying, then what you have to do to the exponent is for you to add. So in this case, the bases are the same, so I will maintain only one base and then add the exponent, which is 1 over x plus 1 over y plus 1 over z. So you can see that it comes out very nice in this case. So you can see that we have our 1 over s, 1 over that, everything intact over there. So multiplying the whole of that also gives us 252. And then remember, since the bases are the same, we just have to equate the exponents, and then 1 is basically, we have 1 here equals to 1 over s plus 1 over y plus 1 over z. So therefore 1 over x plus 1 over y plus 1 over z here equals to 1 in this case, right? So you realize that in all three methods we had the same answer throughout. So thank you very much for joining me in this section. I hope this session was helpful. If you are new here, please like, subscribe, and also hit the notification bell to be notified anytime we post a new video. Thank you very much, and I'll see you guys in the next video.